morning, my YouTube viewers. It is Crystal here, and I'm going to do another video for you on Kaggle's monthly playground competition. And so yesterday they had their last playground competition for the year, and I didn't. And so I decided since I did it, I was going to make a video on what I did and also do a blog post. I mean, if I really had a lot of confidence, I could probably make a video while I was doing the competition, but it would take me a long time to do it. So I think it's best under the circumstances just to do a video on the code review. So this particular competition question is to predict on whether a person is going to get diabetes or not. And so I thought it was a good competition because I've got diabetes. So it was good for me to look at the parameters as well. So the first thing that we're going to do is we're going to make our problem statement. And the problem statement is predict on the probability that a person will get diabetes. That is your problem statement. And then we're going to import our libraries. So we're going to import pandas as PD, which is a data processing library that creates your data frames. We're going to import NumPy as NP, which is a numeric library, and it performs numeric computations and creates NumPy arrays and also creates distributions. We're going to import OS, which goes into the operating system. Then the next thing we're going to do is we're going to import KS2SAMP from SciPy. And then basically what that is going to do is that's going to perform the Kolmogorov-Smirnov test to see if any of the columns of data were from the same distribution or from different distributions. Because if the columns of data or the features are from different distributions, then what that means is your accuracy is going to be lower when you make predictions. We're going to use the Catboostclassifier in this instance, and the reason why we're going to use the Catboostclassifier is because there's categorical columns. And because there's categorical columns, we'll use the Catboostclassifier because Catboostclassifier is designed for categorical features. We're going to import sklearn, which gives you your machine learning functionality. And we're going to import matplotlib.pyplot-splt, which is a visualization library. And we're also going to import Seaborn as SNS, which is also a visualization library. So after we have imported our libraries, what we want to do is we want to retrieve our files. And we're going to use OS to retrieve the files. And then after we have retrieved the files, we're going to end up with train test and sample submission CSV files. So now what we're going to do is we're going to read these files into the program. So train equals pd.readcsv, and then the line address, the link to train, same thing for test and the same thing for the sample submission. And then what we're going to do is next thing we're going to do is we're going to set the program up to where it views all of the columns of data. And if you don't set it up to where it will view all of the columns of data, what will happen is you just won't see all the columns of data. And that's not what we want. We want to be able to see all the columns of data. So this is our trained data set, data frame. We've used pandas to convert it to a data frame. So you've got an ID, an age, an alcohol consumption, physical activities per week, diet, sleep hours per day, sleep time hours, BMI, waist to hip ratio, systolic app, diastolic app, heart rate, cholesterol, HDF cholesterol, HDL, IDL, LDL cholesterol, triglycerides, gender, ethnicity, education level, smoking, employment status, family history, diabetes, hypertension, cardiovascular, and whether they're diagnosed with diabetes or not. So that's your training data. And you can see we check for null values. We do not have any null values. And then test is exactly the same format as train, except for that it does not have the target. The target, because we're going to be predicting on the test set. And then we check for null values, and we don't have any null values. And submission, this is what we want to see when we submit our data. So when you submit your data, you want an ID column and the probability that they're going to be diagnosed with diabetes. So I initially did the Kolmogorov-Smirnov test to check to see if any of the columns are not from the same distribution, but almost all of the columns are not from the same distribution. And since almost all of the columns are not from the same distribution, you only have like 4 columns of data left. And since you only have 4 columns of data left, I went ahead and ran it with the 4 columns of data, and it only gave me about a 62% accuracy, which wasn't very good. So I just hashed out this cell because I wasn't going to use it. I was going to go ahead and keep all of the columns of data in there, even though they were not from the same distribution. So now what we're going to do is we're going to analyze the target, and we're going to create a histogram using Matplotlib to do that. And here's the histogram. You can see that we have a class imbalance. You had more people were diagnosed with diabetes than were not diagnosed with diabetes. But there's also a class imbalance in that target. So now what we're going to do is we're going to pre-process the data and get it set up so the Catboostclassifier can train it. So we're going to sort out the categorical columns. And then so if the train called dtype equals object, we're going to append that column to the cat calls array or list, because in Python there's no distinction between an array and a list. So these are the categorical columns, being gender, ethnicity, education level, income level, smoking status, and employment status. So now what we're going to do is we're going to use Matplotlib to create graphs of all of these categorical features. So here's the categorical features. We've got a categorical feature of count plot of gender, count plot of ethnicity, count plot of education level, count plot of income level, count plot of smoking status, count plot of employment status. So you can see what the different categories are in these categorical features. Okay, so now what we're going to do is we're going to check to see which of these categorical features, the unique values of these categorical features. And the reason why is because in 2 of these categorical columns, you've got other. And Catboost doesn't really record other very well. So we've got to find out which features have other in them. And so we found out the gender and the ethnicity have other in them. So now we replace the other in the categorical columns. So rather than other, it's going to be other gender, and in ethnicity, it's going to be other ethnic. So now what we're going to do is we're going to find out which columns of data are integers. And then when we find out which columns of data are integers, you find out alcohol consumption per week, family history, diabetes, hypertension history, and cardiovascular history are integers. So now what we're going to do is we're going to take all of these columns of data, or these features that are integers, and we're going to plot them on a graph. So you can see we've got 4 columns of data that are integers, and we plotted them on the graph. We plotted the alcohol consumption per week, the family history of diabetes, the hypertension history, and the cardiovascular history. Okay, so now what we're going to do is we're going to take the numeric columns, and then we're going to determine whether the column is a float or not. Because the numeric columns that you have in Python, you've got an integer, which we have just covered, and then you also have a float, which is a full number. So the columns of data where we have floats are diet score, sleep hours per day, screen time hours per day, BMI, waist to hip ratio, diagnosed diabetes. So those are your columns of data with integers. So now what we're going to do is we're going to plot these columns of data using Matplotlib as well, so you can see which columns of data have integers. So we've got alcohol consumption, family history, diabetes, hypertension of diabetes, and cardiovascular history. And then so now what we're going to do is, in order to prepare the data to work in the Catboost, we're going to one-hot encode all of the categorical columns. And then when we have one-hot encoded all of the categorical columns, instead of about 26 columns of data or 25 columns of data, now you have 44 columns of data, because you've got a column of data for every category. And then we do the same thing in the test set as well. So now what we're going to do is, after we have pre-processed the data, then we're going to define our dependent and our independent variables. So with the Y variable, you're going to pop out the diagnosed diabetes column, and that's going to be Y, which is also going to be your target. With the X, it's going to be the remaining columns in the target, and X test is going to be test. And we're going to use sklearn's train test split to split the data set into training and validation data sets. So we're going to now define our model, and this model is going to be a CatrboostClassifier, and so it's going to be loss function is going to be cross entropy, iterations is going to be 1,000, learning rate is going to be 0.1, depth is going to be 6, and verbose is going to be 100. So that means every 100 iterations, it will give you the rate. It will tell you what's going on. So now we're going to fit the model. So we train the model, and you have your 1,000 iterations, and every 100 iterations, it will give you the learn rate, the total, and the remaining. So now we're going to make predictions on the validation set. And we're going to create a histogram of the validation set as of the predictions being widespread as well. So you can see that these are our predictions. And again, you see that there is a class imbalance. We check our accuracy. The accuracy of our predictions is 68%. And now we're going to predict on the test set. So that's going to be a big projection because that's what we're predicting on as our test set. Now we're going to predict on our probability because the problem statement is to predict on the probability of whether a person is going to be diagnosed with diabetes. So this is your predproba, which is the probability of whether a person is going to be diagnosed with diabetes. And then so what we're going to do is we're going to create a histogram of the probability. And this is what the histogram looks like. And you can see that it is skewed to the left. It almost, in sort of ways, it almost looks like a normal distribution, but it isn't. So now what we're going to do after we have predicted on the probability of whether a person is going to have diabetes, what we're going to do is we're going to prepare our submission. And then when we prepare our submission, what we do is we save it. And then after we have saved it, we submit it to Kaggle. And then whenever I submitted my work to Kaggle, I got 69% accuracy. And while you may think that 69% accuracy isn't very high, the highest rate of accuracy was actually 70%. So the reason why it didn't have very high accuracy is because most of the columns of data were not from the same distribution. And since they were not from the same distribution, it was very difficult to get a high level of accuracy. And whenever I originally set up this model or this Jupyter notebook, I wanted to put the Kolmogorov Smirnov test in there and only use the columns of data that were from the same distribution, but most of the columns of data were not from the same distribution, which gave me like a 62% accuracy, and I didn't want that. So I went ahead and used all the columns of data, even though they were not from the same distribution. So that concludes this video. I've done a code review of what I did in the Kaggle competition. If you like my video, please like and subscribe. And thank you for watching my video. And I look forward to making more videos for you in the future of a data science composition.